program, the program which I have discussed on the first day of ultrasonic, where I have kept two ultrasonic sensors. There is a buzzer over here and a LED for visual indication. Now this is a bit special type of LED. It is multicolored flashing LED. Fine. So now here you can see there is one sensor here. Now see, the moment I bring the sensor, because it is detecting the distance of the, what do you say, sensor, it is beeping. See, the beep here is of different type. Is it audible? See, here you can see there's a beep. Fine. If I remove this, now the beep will stop. Now this beep is short beep, and a person, if it is detected from the back, the beep is different. See, the beeps are different. And see, the LED is flashing. Here you can see. This is short beep. If I bring the hand, it will start, and I'll take another sensor. It will give you long beeps. So this is how a social distancing system is designed. Here what I did, one sensor I'll connect to my front body part on the t-shirt in the front, and another at the back. Same way what students can do, can design a small bracelet, and that bracelet can be connected in hand. Fine. So this can be used by a person to detect if somebody is within the range, like within 1 meter or 2 meter, how you program basically. And then same thing can also be used by blind people for detecting the obstacles in between. Fine. They can even put in the specs also, or they can put in the stick and they can use it. So I hope this demonstration is clear. Same way, I'll be giving you one more demonstration, not now, in the mid or the end of the session, where I made a blind man stick with some 3-4 different sensors. Actually, that was a project for somebody have designed. So I'll show you that demonstration also. So using the simple sensors, you can design the applications which can be used in real life. So I hope this till this part everything is clear.
Yes, sir.
Yeah. Anything anybody want to ask? So I hope now the PPT for DHT11 is visible to all. Yes.
Yes, sir.
Okay. So now DHT11, it is a temperature as well as humidity sensor. Now this I've told you some time back also. This sensor has on built in, like on that sensor itself, there is 8-bit microprocessor on it. Fine. So before going to the details, what we'll be seeing today is DHT11, one app which is Blink, and third the cloud which is ThinkSpeak. So all the three things we'll be seeing today. So this is your DHT11 look like. Now this DHT11 may have either 3 pin or 4 pin. One pin is VCC, second pin is ground. Second pin is ground. And the third pin is the data pin. The middle pin is data pin. Now, this particular sensor can give temperature and humidity. Now, for temperature on this sensor, there is something which is called as NTC resistor. Can anybody tell what do you mean by the word NTC? Can anybody tell what do you mean by the word NTC? Yes, anybody? What is NTC? Yes, I'm audible.
Yes,
Then
sir,
tell
you're
me
audible.
what do you mean by word NTC? If it is you know NTC, say yes. If you don't know, say at least no. I should understand. Negative thermal conductivity. Okay. Okay. Hussein says no. Fine. NTC means negative temperature coefficient. When I say negative temperature coefficient means as the resistance increases, what will happen? As the temperature increases, its resistance will decrease. That is NTC. You also have PTC, positive temperature coefficient, in which if the temperature increases, resistance also increases. But we are not bothered about whether the temperature increases, resistance decreases, or the other way around, whether it is PTC or NTC. What we are getting is the output as a temperature value and the humidity value. So it's a 3-pin sensor. So you can say the humidity range is 20 to 90%. Fine. Accuracy is plus or minus 5%. Temperature in 0 to 50 degrees with plus or minus 2%. And it can operate from 3 to 5.5 volts. This is 100% compatible with the node MCU because node MCU gives the output as 3.5 volts. So now, so DHT11 is temperature and humidity sensor and it is giving digital output. I've already told you. It has a 8-bit microcontroller on it. Now, a resistive sensor will give the temperature as there is a capacitive sensor. Now, capacitance, when I say capacitance, it has two parallel plates. And those two parallel plates basically forms and there is a dielectric in between. Now, the dielectric is a non-conductive material. So the charge stored in the capacitor changes with the dielectric medium. So if the dielectric medium is more humid, the capacitance will be different. Less humid, the capacitance will be different. So here the humidity is converted into the capacitance and then it is measured. So that is what is the benefit of DHT11. We also have DHT22 also. That is DHT22 also. So here you can see it has, just a moment. Fine. So there is a capacitive and there is resistive temperature element. So calibration is done and it is a simple 3 or 4 pin single row package. Basically, it is a single wire communication serial interface. Why single wire? Because one is VCC, other is ground, and third is data. Fine. And what it says, it is small in size, low power, distance up to 20 meters we can use it, 20 meters. And when you design a project for agricultural purpose, fine, this is the main sensor which can be used. So these are the two sensors which are available inside DHT11. This is for humidity and this is for temperature. Fine. And this is what is the construction of the capacitor. This is upper plate, this is lower, this is the lower plate, and this is the dielectric between them which absorbs the moisture. So the data which this sensor gives is of around 40 bits. Fine. Out of that 40 bit, first 16 bits are basically for humidity. You can see here. The next 16 bits are for temperature, and the last is checksum. Now, why checksum is needed? So that when the data is transmitted, a checksum byte will be transmitted along with this. At the receiver end, again a checksum can be calculated of all these values, and this checksum will be compared with this, and if both are same, then definitely the data sent by the sensor has not changed. Because when I say 20 meters distance, there is possibility that because of noise in the atmosphere or the nearby lines, the data may get changed. Data may get changed. So to avoid that, there is a checksum, but for short distance, we are not taking care of the things. Fine. So the first 2 bytes are humidity, second 2 bytes are for temperature, and the last byte is for checksum. Now here, take an example. Temperature is 37 degrees. So you can say this is 1, 2, 4, 8, 16, 32. This is binary numbers. So this is 32 plus 4, 36, and 1, 37. Same with 25. It is 1, 2, 4, 8, and 16. So 16 plus 8, 24, and 1, 25. In this way, the data will be sent, and then the checksum byte is computed and the checksum byte is also transmitted. So this total 40 bytes is transmitted for the data as a data. This is a checksum. Now, here we need a library. Fine, we need a library for DHT. Now, that library is, just a moment. Okay, here I need a library DHT that is to be downloaded from the net. You can download it and you know how to install it. Can anybody tell me how we can install the library? Yes, can anybody tell me how to install the library? 2 ways I've explained you. 2 ways I have explained you. What are the 2 ways of installing libraries? Anybody? Yes. Students, at least let me know so that I will understand how much you have understood. What are the 2 ways we have seen to install the library? Anybody? Do you remember or not? See, if you don't answer now, Geeta ma'am won't issue the certificates, okay? Ma'am won't issue the certificate to you. Yes, Geeta ma'am.
Yes, sir, very true. We are doing a lot of effort for these students only.
No, at least they should reply something.
Students, please, sir is asking if you don't know simply or if you are getting stuck at any place, please inform to sir.
Yeah.
Otherwise, how the will continue with, please, students. Write down
Yes,
into your chat
students.
box or unmute and talk to directly to the sir.
Yeah, you can. So what are the 2 ways I've explained you to install the libraries? Yes, you can download the library, unzip it, copy in the library folder. Okay, this is the manual process. Very good, Pradeep. Next. What is the second way? What is the second way? From IDE. Okay. Aditi, how in from the IDE? How from the IDE? How from the IDE? From the board section. Okay. Are you confirmed that it will be the board section? Yes. See, if you don't know now, just let me know, sir. Don't, if we didn't remember, no issues. I'll explain you again. See, manually, what we have to do is we have to download the zip file. After downloading the zip file, what you guys can do? Yeah, after downloading the zip file, you can unzip it. After unzipping, copy into the libraries folder. That's fine. Second way, we have to go to Sketch. In Sketch, there is include menu. There you have to go, and then add zip. There is an option. You can include that, and then you have to give the path, which will include the file. Now, in this code, you can see dht.h is included in our project. Fine, dht11 is included. Now this dht11, now this dht is the class, this small dht is the object, d2 is the pin to which I will connect. Now in the diagram it is d3, but in my code I've used d2. Fine, so there is no problem. You can make it d2 also in the diagram. You can see here. Fine, you can see here it is d3. So what I'll do, I'll connect this to d2. Then dht11, because there is dht22 also, so I have to specify which sensor I am using. So this library is compatible with dht11 as well as dht22. Now I've taken two variables as a float, humidity and temperature. And that what I'm doing, setup, I'm just writing serial.begin, which will start a serial communication because I'll take the data on serial monitor. And then I'll take dht.begin. Now this will start my system. And now in loop, what I have done, I've written loop humidity equals to dht.read humidity. So out of that data, which is of humidity plus temperature, humidity part will be available to me in this variable called as humidity. Same way I will write read temperature. So I'll get this temperature part in temperature variable. Now what I'm doing, serial.print, I'm writing print. So this next line, humidity will be printed ahead of that. Fine. Then comma, I'm writing print temperature, and this is the see, it is in double quotes, so it will come as a temperature, and then the temperature value will be printed. So how I'll get the output, humidity colon some value comma temperature colon some value. Fine. And then again same thing will be repeated on the next line, and it will read the data every 5000 milliseconds, that is around 5 seconds. So every 5 seconds this data will be read. So this is how the system. So very simple code. You have to just use the library and add up the code. So I'll just switch on to the IP cam. Fine. IP cam screen is visible to all. Yes, IP cam. Okay. So you can see this. This is a. These are the other sensors. Fine. You can see the sensors here. DHT sensors. And in this DHT sensor, we have 3 pins. Here also there are 3 pins. Here also there are 3 pins. One is VCC, second in data, and third is ground. Fine. So what I'll do, I've taken this node MCU. I'm just showing you node MCU. Now this is the node MCU. In this node MCU, you can see here 2 wires on the one side. These 2 wires are VCC and ground, and this is D2 pin. This is D2 pin. This is D0, D1, D2. This is VCC and ground. This is 3.3 volts pin. So red one is 3.3, brown is what do you say, ground, and the black one is the data pin. So this red is connected to VCC, brown is connected to ground, and so this you can see the setup. Fine. Now I'm connecting. Just a moment. Fine. So you can see the LED is glowing, means at least we can say the sensor is working. Now I'll take up the code. Fine. This is what is the code. I'm just a moment. So I hope code is visible to all. So I'm transferring the code in node MCU. So you can see the compiling status over here. Fine. I hope this programming part is visible to you all. Okay, thank you, Vishali. See, the code is being uploaded. Okay, uploading done. Is this IP cam window visible to you all? So you can see the, I hope now two windows are visible to you all. On one side, there is temperature and humidity, which is coming. And on the other side, the IP cam sensor is connected. Can you see both the windows?
Yes, sir.
Okay. So you can see this temperature, humidity I'm getting is 32.60 and temperature, I'm sorry, humidity is 82 and I'm getting temperature as 32.60. What I'll do now, just I light a small candle or a incense stick and we'll try to increase the temperature and see whether the temperature and humidity is changing or not. Just give me a moment, I'll get that. So I'm bringing a source of temperature near. Let's see whether the increasing there or not. So even this agarbatti can also be used along with air purity sensor to give some pollution inside the air. Generally, what I do, I use a normal incense stick. I use mosquito coil. I use mosquito comfort this to generate different types of impurities in the air. See, the temperature has increased to 43 and humidity has gone down. Why? Because of this heat, the humidity has reduced. So I hope you can see on the screen. Let's wait for some 2-3 minutes. Let's see this temperature as well as humidity coming down. Now till this temperature is increasing and now she started decreasing also. So now till this temperature goes down and we see again it is coming to the normal. Till that point, students, one question for you. Now, using this temperature and humidity sensor, what all projects you can think that you can design with this sensor if this task is given to you? Just give me your answers. What all you can think and where the sensors can be used so that we can design some few projects on that. Yes, students, I want a reply from you. Think and tell me what all projects you can design. Suppose ma'am gives you a task that you have to make use of this sensor. What you guys can do? I'm audible. Kitchen chamber, okay. Automatic home temperature control system, okay. What all? What else? To check the humidity in the soil for the farming purpose, okay. What more? See, the temperature has came down to 33.20 degrees. Now, student, one small task for you, that you have to design a system modifying this existing code, that when the temperature is below like around 32 degrees or around 32 degrees and below, it should beep. And if it is more than 33 degrees, it should above 32 degrees it should beep, and below 32 degrees it should stop beeping. Just modify and tell me the code how it will be. Fast. Everybody has to try the code. I've already given you the code. So what you guys will do, you have to modify this code. So what changes you will do, just let me know. Egg incubator, yes, very nice application. Same way it can be used for baby incubators also. It can be used for baby incubators. See, why I'm asking you this, because if you are in the second year or in third year, you can think for the IoT projects on these topics. Chalo fast. Tell me what are the changes you will do in the code so that it will be above value and it will stop beeping below a value. So the moment temperature becomes 33 and above, it should beep, and below 33, it should stop beeping. I have done some changes in the hardware. I have connected LED also, but there is no action on the LED right now. Yes, students, tell me the code fast. If temperature is greater than 30, buzz high. What should be the command for that buzz high? What should be the command for that buzz high? Give me the exact command. What should be the command for buzz high? Digital write, complete command. Can you give the complete syntax? Complete syntax. Yeah, it's correct. Fine. What we will do, we'll do some changes here. Very first thing, I'll write here pin mode D3 comma output. Okay, so it will make my LED connected to pin 3 as in the output mode. I want to set the pin as output. So you can see here, I've made that pin as output. Here, this pin number 3, I've connected LED to pin number 3 here. This red wire is for pin number 3. I'll show you that while giving the demonstration. Then just for testing purpose, what I'll write digital write D3 comma high, and then I'll give delay of 2 seconds, and then I'll make that as low, and I'll write delay of 100 milliseconds. So now I have tested this particular routine. This we generally call it as testing routine. Even we call it as power on self test, which also called as post. Yes, Rushali, correct. Digital write, but there shouldn't be any space between digital and write, and W should be capital. Now, after reading this humidity and temperature, what I'll do, if T is greater than 33, what I'll do, I'll just write this. Digital write high. Fine. And no delay, nothing, because delay is there. Already delay of 5 seconds is there. I'll just make it for 2 seconds. So every 2 seconds, the readings will be updated. If again, I'll write if the temperature is less than 33. Remember one thing, all the conditions you should specifically test. If T is less than 33, then you'll make it digital write low. So done. Our code is done. I'll just program the node MCU. Have you heard the beep? That beep was for testing. Got it? I'll just turn on the serial monitor. First, I'll clear the output, and we can see the so it is the temperature I'm getting is at 32.3 degrees. What I'll do, I'll just press a reset. And one more thing I like to add is, if suppose sometime your controller is not programming, then you can even try pressing the flash button. See here on one side there is a reset button. Here there is a reset button. This is reset, and here there is flash. So I just press the reset button. So it is beeping, and then it's see some garbage is given because it is resetting, and after that it has given beeping and started with the temperature that is some 32 point something. Now what I'll do, I'll just bring that stick near it, and we'll wait for temperature to increase up to 33 degree. See, started beeping and the LED is glowing. I've connected buzzer and LED to the same port, so both are working at the same time. So now let the temperature come down below 30. It will stop. Now see, it started decreasing. It came to 33.4. 3. So student, till the temperature comes down and beep stops, just let me know how many different sensors we have studied from the day 1 till today. Just make a list of it fast. How many demonstrations we have seen of the temperature? I'm sorry, how many different sensors? See, yeah, the temperature has reduced to 32.9. Beep has stopped. Fine, students, just let me know how many sensors we have used till date in these sessions. Temperature sensor, gas, fire, flame, great. What next? Other than that, touch. Okay. So chalo, let's see how much sensors you can recognize. There is one sensor which is kept over here. This is DHT11. Which is this sensor which I've kept now? Yes, fast. Answer it. Gas sensor. Very good. Now this one, which is this? Fast, fast. No, it's not PIR, not even LM. Students, सिर्फ 2 या 3 दिन ही हुए. It's a very short term memory. Yeah? Your memory should be long term. Memory should be LM, not SM. Yes, anybody else who will try this fast? Which sensor is this? No, this is fire sensor. This is fire sensor. Now tell me this one, the next one. Which sensor is this? Yes, which sensor is this? This is PIR sensor. PIR, very good. Coming to the next, this one. This is obstacle sensor. What it is? Obstacle sensor. Coming to the next. This is sound sensor. Coming to the next. This is touch sensor. And then I'll show you one more. This is soil moisture or humidity sensor. You can see this. This is soil moisture, humidity sensor. So I'm just keeping it here. Soil moisture and humidity sensor. Now these are available in different form. These are available in probes, and if it's available in the plate format, if there is a plate, then it is water sensor. In a probe, it is for soil moisture. Can anybody tell me that using this sensor, other than home automation, kitchen automation, industry automation, what system you can design other than this? Okay, in agriculture, okay.
Traffic control management system, sir.
Traffic control. Can you just elaborate how, madam?
Sir, by making a specific path, by keeping obstacle sensor somewhere I read, hence I'm saying.
No, with obstacle sensor we cannot. But then,
Okay.
see, very first thing, for traffic signal control, there is no need of obstacle sensor. Obstacle
Okay.
sensor you can connect on the roadside, and you can
Hmm.
define that. You're correct. You're correct. You can define the traffic density on the road, and
Yes.
depending upon the traffic density, this can be controlled. This project I have designed in my diploma somewhere in
Okay.
2002.
Okay.
Very good example. Very nice example. See, madam has given.
Because sir, this only I presented this topic embedded system in my refresher course. So I
Oh,
gave
great.
this example. I
Great,
made an
great, great. Very
architecture.
nice. Very nice. Very nice. You can connect at the both side of the roads these IR
Yes.
sensors, and you can find out the density of the traffic.
Yes, sir.
Fine. And depending upon that, switching of the traffic signal can be done. Very nice. Using this ultrasonic and IR sensor, we can have a nice vehicle parking system, that when we take a vehicle reverse in a garage, fine, a distance between the wall and the vehicle can be detected. And once the vehicle is stopped, automatic door closing of the garage can be done. Apart from that, using this water sensor or the soil sensor, you can make automatic wiper system for the car, that when the rain starts, wiper will start moving. Using this LDR, light sensing register, you can find out, you can, what do you say, design the, what do you say, light sensing system. You can design like when there is dim light, so when all of a sudden there is an evening or night, the headlights of the vehicle can start. Apart from that, using a temperature sensor, this humidity and temperature sensor, AC can be controlled in the car. Apart from that, You can use this sensors, what do you say, light sensors to detect the fog and to control the headlights. Fog detection can also be done. Such there are n number of small applications we can do.
So, sir, what about face recognition system?
Face recognition system, you need a camera and you have to use
Okay.
AI.
Okay.
I'm designing one project for my BE students, along with my BE students.
Okay.
In that, the cameras which are connected on the roadside, they will take the picture of the people who are spitting, and with the face recognition, they will be sent message that the moment they are detected spitting, their face will be recognized, and they will send a message of fine, how much they have to pay.
Okay. Okay.
Also, that system will detect who are wearing the mask and who are not wearing the mask. If they are not wearing the mask, face will be detected and the message will be sent to them.
Okay. Sir,
Any other applications can you think
sir,
of? Yes.
Sir, any other application, flood detection system, is it possible?
Yes, yes. Why not? It is surely possible.
Okay. And if suppose sir gas is leaking,
We can use gas sensor.
okay.
We can.
And health monitoring system, sir?
We can do health monitoring. We can do
Using
even using gas sensor and MQ135 air purity sensor, and
okay.
including your carbon monoxide sensor and oxygen sensor. You can have a weather air quality management system.
Okay.
You can have a nice air quality management system.
Okay. Okay. Okay.
That way. Even very nice example you can take. Somebody has on my YouTube, somebody has given me alcohol detection system by using the alcohol sensor. Very good.
Yes, sir.
One of my friend, Mr. Narendra Ahuja, he has given very nice that it can be used in defense as well as in police.
Yes.
So
Yes.
yeah, lot many applications you can think of and you can design it, because methane gas, propane gas, butane gas, all are these toxic gases which are coming out of these chemicals. So bomb detection can also be done. Fine. So even very nice example of this light sensor, I can say. You have a light sensor which can be connected in the pathway. Like take your college as an example. Now in your college, in the path, like in a gallery, complete lights are on and so they remain on. Suppose what we can do, we can connect sensors at some different point. The moment some person crosses, that much amount of light will be turned on and see, suppose in a gallery there are 100 tube lights and all are 100 remaining on, that is a disadvantage. So what can be done is we can connect the sensor and hardly 20% of the tube lights can be kept on so that there is limited light. And the moment person start moving, some tube lights beyond him and some tube lights back at the back of him, that can be turned on. As it moves ahead, the tube light will go on switching. So we can have a nice energy conservation. Hello, I'm audible?
Yes. Yes, sir.
Yeah, so same can be used in the skywalks or in the stations. Everywhere such concepts can be used.
Yes, sir.
Okay.
So, sir, smart street light also can be done like this. Waste management systems also.
Yes. Using IoT, you can make a smart system so that light can be controlled, as well as you will get a message or the indication whether in the daytime that by mistake, due to the damage of the sensor, the light has remained on. It can send a message to you that this light is on, so you can manually control that light from your end.
Okay.
So that can be done.
Sir, I read somewhere, what is the meaning of cradle? IoT system, cradle, what is that?
Cradle. See, now there are new terms, many new terms have evolved. I've not yet come across anywhere like this term.
Okay.
But definitely I'll let you know what it is.
Sir, one of my students, she designed this baby health monitoring system using
Okay, very nice.
temperature sensor like that.
Okay. And ma'am, if your students have any difficulties regarding the project, regarding the sensors, anything they want information, they can contact me anytime. They can put me a message on my WhatsApp number. I'll help them out.
Okay, sir. Okay. Sir, we do encourage students to now, and rather than making website, Windows project, go with IoT projects.
Yeah, we should stop this website and VB projects and VB.net and all those things. Rather, we should move towards Python as well as Java server, and also it is very nice. We should go more towards IoT because that is what is the future. And already I have told you the new concept which evolves in your mind. If you're implementing that and if it turns out to be very nice, definitely your startup is on. I'll tell you one simple nice example. हम जो मास्क लगाते हैं बार बार मास्क निकालो बंद करो मास्क निकालो बंद करो, you know, हेलमेट जो होता है, हेलमेट का जो ग्लास है, ग्लास जो ऊपर नीचे होता है, we can connect motor to that helmet and that glass, if we need, automatically can go up and come down. That can be done. Helmet can be made ventilation proof. With ventilation, helmet can be designed with sensors so that if you have drunk with alcohol और हेलमेट डाला तो गाड़ी चालू ही नहीं होगी. It won't start.
सर अभी ऐसा भी तो था जैसे कोरोना में मॉल्स खुले थे तो at a time 5 people only can be inside, so they made an IoT system which is automatically seeing if 5 people are inside, so if any extra person is coming it is not allowing.
Exactly, that can be done. That can be done. And even a very nice application what I thought of also the mask. What you can do, you can connect to one motor and two lever at the helmet, your face end, and you can connect a mask. So whenever need, that mask will come up, again the mask will come down, like shutter opening and closing.
Okay.
That also can be done.
So like this doorbell also system can be made now using IoT.
Yes. I've given the demonstration on that day. Connecting a buzzer, you can make a doorbell. Even you can make a what do you say, the courier sanitizing system. Whenever some courier person comes, the moment he puts the courier, you can have a small spraying system on that, so it can be sprayed with a sanitizer. Even hand sanitizing system can be done. Even using motor and using your sensors. जो हमारे टेम्पल में आरती और गोंग बजता है, फाइन, तो आरती के लिए मोटर रोटेट होगी, उसका मैकेनिज्म बनाना पड़ेगा और गोंग बजेगा. मतलब आरती भी आपको कुछ नहीं करना है, जस्ट खाली वो आरती के जैसे हम आरती लेने के लिए हाथ आगे करते हैं ना, बस खाली हाथ ही वैसे आगे करना है, ऑटोमेटिकली आरती विल स्टार्ट मूविंग. See, you can think n number of applications with this. And students, you should come up with some new such ideas. Got it? Soon I'll be keeping one such competition on my channel with the new ideas. Those who will implement, definitely there will be some prize for that. I'm coming up with that concept also.
So sir, question is, can these systems be linked with like WhatsApp, Telegram? Is it
Telegram
possible?
we can link. Telegram we can link. WhatsApp doesn't give the API, but Telegram does. So we can link with Telegram. We can send a email. We can link up with email. We can link up with Twitter. We can have a push notifications. Lot many such applications are there. You can do it.
And what about the Google Sheets?
No, Google Sheets we cannot link. But Excel sheet, out of that data, we can generate Excel sheet. Like when I'll be connecting to ThinkSpeak data can be downloaded in terms of Excel sheet, and that Excel sheet you can upload it on the Google and you can connect to Google Sheet. That can be done, but directly data cannot be entered in the Google Sheet.
Okay.
Yes, students. Designing for heavy machines. Okay, automobile designs for heavy machine. Vikas Yadav give a nice idea. Very good, Vikas. Yes, ma'am. Any other thing?
Sir, it means when you showed that example, localhost, we were connecting server, right? So we can manage our web server also using IoT, right?
Yes, ma'am. You can. That is a complete different project where you can take a data from the sensor. The data will be transported to ThinkSpeak. From ThinkSpeak, I can connect it to my website, and on my website, I can see all the data. That is also possible.
Okay.
Lot many things are possible from here.
Yes. Kind of managing electronics, power electronics projects also, right? So
yes.
Robotics project.
Yes.
So sir, what do you think if whenever any these kinds of systems are made, we should use Arduino or Raspberry Pi? What do you suggest?
See, ma'am. See, very first thing, for such small system, Arduino, I won't suggest even Arduino. I'll suggest Node MCU, because Arduino का problem क्या? Arduino के साथ ESP8266 use करना पड़ता है. Fine. और Arduino और ESP8266 costly पड़ता है. ठीक है? Plus ESP8266 में 80 commands use करना, तो 80 commands और हमको पढ़ने. 80 commands are attention commands, which are used for interconnection. So instead of that, if we go for Node MCU, we have many libraries available so that our work become bit easier and
Okay.
our sensors will become cheaper. Now,
Okay.
if you want to collect the data, suppose from 15-20 sensors and process it, then what I'll recommend is using this node MC you can design the sensors. हर node MCU में 2-3 sensors लगा दो अलग अलग, जैसे suppose आपका कॉलेज है, कॉलेज का एक फिजिक्स लैब है, केमिस्ट्री लैब है, बायोलॉजी लैब है, तीनों लैब में एक एक नोड MCU लगा, उनके साथ सेंसर्स कनेक्ट कर दो. Fine. So 3 sensor nodes have become, those sensor nodes will give data to Raspberry Pi. Raspberry Pi will process because it has operating system, it's like a computer, so it will process that and then you can go ahead.
Okay.
Like this IoT course, even I have a IoT, this was IoT course with Node MCU or Arduino. I have one IoT course with Raspberry Pi also.
Okay. Okay.
So Raspberry Pi is totally a different concept.
Okay.
But that is used for bigger system for real-time processing and all. They this
Okay.
can be used for smaller system. I'll recommend to use either Arduino or Node MCU.
Okay. So sir,
Even
but then which protocol has to be used? There are some protocols, na?
No, here we are not
MQTT.
using any, just we are using UART, simple, sorry, asynchronous, sorry, universal asynchronous receiver transmitter, only that much we are using.
Okay. Okay.
Fine. If you are going for bigger system, definitely we can go for the other options.
Okay. 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 Sir, thank you so much.
Yeah. That should be discussion, then only it is fruitful, or else just it is like one way. I'm telling you are listening. I don't know whether you are getting it or not getting it. All those things, it should be known to you.
Yes. Yes. Students, in fact, you can also ask the questions to
Yes,
sir.
yes, you can. Since we have started a session in between, let's complete this and then we'll go ahead.
Yes, sir. Sorry. Yeah, we'll go
No,
ahead.
it's okay. It's okay. It's really good session. Yes, students, anything you want to ask? Students, anyways, if you ask anything wrong or vague also, don't bother. I cannot see or I cannot recognize your face also. So don't take tension about it.
I think, sir, we'll go ahead. Yeah.
It also who all are doing the IoT project for their TY level. If any questions related with that, you people can ask to the sir that questions also.
Yes. Anything. I've already told you. Even if you have any difficulties, any issues, you can do a WhatsApp. I'll share at the end of the session. Just remind me, I'll share my number.
Yes, sir. Sir, we'll proceed further later,
sure,
maybe.
sure.
Yeah.
I'll just a moment. I'll share the number so that if they have any difficulty, they can put it to me.
Yes, sir.
Students, this is my number. This is my WhatsApp number. You can have any difficulties in your project, or if you want any information, you can contact me. Fine. And even I have 4 channels with the name of Kavedia sir, but there is only one channel of Kavedia sir. On that also you'll find lot many videos related to Tinkercad, Arduino, and Python. Many different videos are there. Even 2-3 projects also I have uploaded. Soon I'm coming up with a new channel on which small videos related to project ideas will also be there. So you can be in touch with those channels and you can find out lot many different concepts, which will definitely help you out in implementing the new concepts. Chalo, fine. We'll move on to the next further session. So it was very nice talking. Madam was really enthusiastic and very energetic, I can say. Chalo. So our next part is Blink app. Now, those who want to practice with me, see, you cannot control, but at least you can try to configure the Blink app with me. So students, what I'll do, I'll just give you 5 minutes. You download the Blink app and install on your mobile phones. And once the installation is over, just let me know. Just write installation done so that you can work along with me on the Blink app. I've written the spelling. It is B-L-Y-N-K. It's not B-L-I. No, it is not B-L-I. It is B-L-Y. So guys, you can install along with me. Great. Shifa has done. Very nice. So others also do it. And within next 2 minutes, we'll start. Great. So only one, two, only two. What about others? Are they doing? Okay, do it fast. Okay. Okay, fine. So what is Blink basically? Now Blink is a server and we have an app. This app is available for iOS as well as the Android phones. And this app can be configured. You can customize this app. So by default, it is giving you 2000 points as an energy level. And the moment you start using these components, it will be deducting that much amount. Let's say for button, it takes suppose 200 amount. So out of that 2000, it will take 200. Then let's say for a slider, it takes another 400. So it will remove that 400. So up to 2000 points, you can use this app freely. But if you want more component for you, then definitely you have to pay to them. But then once you have used this app component, suppose I have designed a system with 4 buttons. Now let's say 4 button was costing 200 points each. So my 800 points will be lost and the remaining points will be 1200. So once my application is over, if I remove this button, again, I'll get my 800 points back and it will restore it to 2000 points. So once your application is done, you can remove the components and then again, you can reutilize those 2000 points. Fine. So that is a mobile app. There is a Blink server. Now here, there is no need of any laptop or so. Fine. There is no need of laptop. You need an internet access of either internet, either through Ethernet, Wi-Fi, 3G, any of the type internet you get. And it's always better to use Node MCU. You can work with lot many different types of hardware that I'll be showing you. So now, Blink is a platform with iOS and Android app to control Arduino, Raspberry Pi, and other like over the internet. Now, one more thing I'd like to add you, like an Arduino board, or you have your Node MCU. There is also one processor board which is called as MSP 430. Fine. Here we have Arduino IDE. It has an ID, is called as Energia, or you can pronounce Energia the way you want. So there is same one more controller that is called as MSP 430. Fine. So it is a digital dashboard where you can build a graphics interface for your project by simply dragging and dropping the widgets. So there are a lot many widgets. I've told you it is giving you 2000 points to use those widgets. So you can see the once you turn on the blink, you will see new project. So what you guys can do, you can have a new project, you can sign up by creating a new account, or you can use the email ID. But remember that email ID, because on that email ID you can get the key or the API key to use that particular app. We need one key, it will be sending that key. Fine. So what you can do, you can make a new project. Fine. And you can log in with your email and password. And then after creating a project, you have to give a name of a project. Give the name of a project as Internet of Things. You can give the name to the project as Internet of Things. We have to select Node MCU as the controller. Fine, because we are working with Node MCU. And then what you can do, after taking the controller, you have to take the connection type as Wi-Fi. So here you can decide like whether to take Wi-Fi, or you have to take a Bluetooth, or you have to take a Ethernet, whatever you want, you can take whatever system it is connected to. Then you can select the mode, whether light or dark. Fine. So these three settings, you have to take Node MCU, Wi-Fi, and the theme. So how many of you have reached till this point? Anybody is trying with me? Yes. If you are coming till this create project, just let me know. Till if you have reached the create project.
Sir, but the screen is not visible with the app. It is just only showing the slide.
Okay. Now?
No, sir. Now it came, sir. Yes,
maybe freeze because of the internet. I'll do one thing. I'll go back one slide. Now it is visible?
Yes, sir. Yes.
Okay, fine. Just let me know the moment this happens, because there's an issue with the net. Screen may get freeze also.
That's what, sir. I was also wondering why students are not seeing anything. Students, if you're not able to
at least let me know. So you can create a project. You can log in with your email ID. Fine. Select Node MCU. And then select the Wi-Fi and say create. If you reach till the create point, just write create on the chat box. Just write create. Okay, Shifa has created, Praveen has created. Who else? Okay, Vrushali has created. Now guys, even you can see this widget box. This widget box button is of 200 energy level. Slider is again 200. Vertical slider 200. Timer 200. Joystick. But we'll be using button as well as the slider. These two components only we'll be using today. Out of 65 students, hardly 3 are doing online work. What about others? Okay, Hussein, I'm waiting. You just do it. I'm waiting. We'll see to that everybody does, those who are working along with me. So once you finish, please write create. Okay, Pradeep has done, Sohail has done, Hussein has done. Very good. Fine. Now what you can do after, now you do one thing, add one button as a widget. Add a button. Everybody add a button. I'll be giving you the live demonstration for this also, how to use the widget and all. But let first let you try. Okay, added. Now once you added a button, what you guys can do, you can give the name to that, whatever the name you want to give for the button, you give the name. Select the pin, D2, D3, whatever you want. Fine, I'll select D3 because I've connected LED to D3, and change the button from push to switch. Change the button from push to switch. Can anybody tell me what is the difference between push button and the switch button? Can anybody tell me what is the difference between push button and the switch button? If you can give an example, okay, fine, it will be better. Push and hold switch are like normal switch. If both are normal switch, then why there are two different names? See, push button is like your button of the bell. When you just press it, it will be turned on, and if you release, it will be switched off like a bell. That is a push button. Fine. But the switch is like when you press it on, it will remain on. When you press it off, it will remain off, like a normal switch in the switchboard. So bell button is the example of push button, and another is a switch. If even if in a lift, you can see when you press and release, immediately it get released. That is a push button. Fine. So have you done till this point? Now you have to, this zero indicates a low and one indicates high, the normal as it is. So the next, we'll see the code. And then I'll give the demonstration for the same. So now here, forget about the first line. It is just by mistakenly added. You just forget about that line. I have to include blink simple ESP8266 underscore SSLH.h. This is a library which I have to add. Fine, this is the library. Second, I have to add SSID and the password. Now this will be, I've kept X, Y, and Z because I have to, you will use your SSID and password. And this is the authorization code which will be available with the Blink app. I'll tell you where it will be. Then what you will do, void setup. Fine. Serial.blink 9600. Then blink.begin. In that you will pass authorization code. This authorization code allows your Blink to get connected with your application. Fine. If you use anybody else authorization code, then the data will go in his system. Fine. And then comes SSID and password. Fine. And then I'll write blink.run, a very simple command, blink.run. That's it. The system is done. Then your control comes to the Blink app. The complete control will come to Blink app. So again, I'll just go first. After you have to download Blink simple ESP8266 underscore SSL.h. So you have to download this library. You have to give your SSID, your password, authorization code, and then the setup to begin. So I hope the code is clear to all. If you have any difficulty, just please let me know. Yes, any difficulty, anyone? Okay, fine. Just give me 2 minutes. So guys, you can see the Blink app on the screen. Yes.
sir.
Okay. I'll go to new project. I'll give the project name as Internet of Things. And then I'll select. See, there are a lot many hardwares available here. You can see. Fine. You can see a number of hardwares which are available. So I'm selecting Node MCU. Then I've selected already the Wi-Fi is there. You can select Ethernet, USB, GSM, whatever you wish. Fine. I have say create. Now see, there is an auth code. Fine. What it says that authorization code was sent to your email. You are alone@yahoo.com. So authorization code has been sent to that particular mail, which is my registered mail. I'll say okay. Now suppose if you want to find your authorization code, from where you will find? See, can you see on the screen? Email all, and after that there is copy all. Can you see that? So that copy auth code, I can copy it from here. I can share it on my WhatsApp. So even I can take it from there too. So I'm not giving it this to anyone. I'll just put it on my screen. So I'll put that on my. So auth code is available with me. Always try to take it from email. Don't try to type it, because if you try to type it, what will happen? Unwanted. If there is a mistake, then all thing will go wrong. Fine. So now what I'll do, I'll go to widgets. From widgets, I'll select one button. If you press it long, after pressing long, wherever you want, you can drag this. Fine. So I'll just click this button. Now I'll make it on. There are two labels, on and off labels. Whatever the way you want the text, you can select. Even you can select the color of the button. So once this is selected, the button will look like that. Fine. The button setting is done. Fine. Now there is a next button. You can see there's a button, arrow button. Okay. I'm just again pressing it. At the end here, there is an arrow button. Fine. When I click this arrow button, it will run the system. Now, but the moment I run the system, see what happens. You can see there is a red dot over here. I'll just press what is there in that red dot. So it said Internet of Thing wasn't online yet. Means it is not yet connected to my system. Fine, it is not yet connected. So again, I'll stop it. My one part of the thing code is over. Now what I'll do, I'll go to my WhatsApp and I'll try to select the auth code also, authorization code from here. This is the authorization code which I've taken. And again, I'll go back to my coding part. I'll select the code which I've explained you. And here I'll copy the auth code, authorization code. And then here I'll write my SSID. And here I'll write the password. Fine. So this thing is done. I'll just try to compile this. Till that time, I'll again go back to my screen. So let's see what happens. So I've done the 3 changes over here in the code. So just writing the code. Access denied. Okay, okay. Understood. Fine. I think serial monitor was on, that's why it was giving access denied. Let's see. Yeah, started writing. Okay, done uploading. See, there's a message, Internet of Things connected. Have you seen that message? See, here it is, Internet of Things connected now. And now if I run this button, now see the red dot has gone. You cannot see that red dot. So now what I'm doing here is I'm making the screen smaller. And I'll turn on this also. Okay, now can you see both the screens? Can you see both the screens?
Yes, sir.
Yeah, I think I have selected D2 pin, correct? Let me change the pin. See, this is turned on. The message has changed to on. Can you see this? And if I just press it off, It is off. Fine. It takes some time because the switching time is needed, and it is a internet two-way communication going on. See, this LED is clicked. It is beeping. The moment I press a switch, it is off. Again, I'll press, and again I'll press off. Fine. So I think this concept is clear. Anybody, any difficulty? If you want to ask me anything. So I hope you understood how exactly the things are working. Yes, anyone? So this is on. This is off. Now suppose if I want to make a robotic device with this, I can have 4 switches, 5 switches, one for forward, one for reverse, one for left, one for right, and one for stop. In this way, I can use 5 buttons and it will function very nicely. Got it? So any difficulty, anything you want to ask regarding this, or we'll go for the next part of it? So even soon I'll be conducting the robotic workshop also. Some few demonstration I'll be putting on YouTube, so you can see that. I have robotics with IoT, Raspberry Pi with IoT. I have Arduino with IoT, Node MCU with IoT, MSP 430 with IoT. Lot many such IoTs are there. Yes, anybody want to ask anything, or shall we move further? Next part of this same experiment. So now what I'll do, from the widget, I'll select slider. I'll click the slider. Fine. So see this. I have to control the LED. Okay, it is telling used. So what I'll do, okay, I'll remove this button first. Suppose I want to delete this component, that's what I'm supposed to do. I'll click this component. I just slide down. There is a delete button. Just press a delete and say okay. The switch will be deleted. Now what you will do? Again, I'll click this. I'll select here D3. Now see, previously it was showing used. Now it is showing D3 PWM. All the switches are PWM switches. Okay. Fine. So send on, release on. So the moment I'll release the button, it will send the code. Fine. And show the value on. Send on, release also on. Now tell me one thing. What should be the minimum and maximum value of this slider? What should be the minimum and maximum value for this slider? Anybody? What should be the minimum and maximum value for this slider? No, it is shown 1023. It is showing. And since if it is 123, why could I have asked this question? But good try, Vrushali. Tell me what was the maximum value which we have given in analog write, and why that particular value we have given maximum value, and why that particular value. Just let me know. Yes. No, not 1023. I'm just connecting one more LED over here. I'll do one thing. I'll connect other way. So one ground pin will be sufficient for me. Okay. I've connected one more LED. And I'll connect. I've connected one more LED. Fine. The one which is flashing, I can turn it on and off. But prior to that, we'll see this value. Remember one thing. Yes. Praveen Kumar, correct. It is 255. Can you tell me why it is 255? Why it is 255? Why 255? Because it is 8-bit system. It is 8-bit system. What I'll do, I'll keep the send on release off. Fine. And now interval between the send is 100 milliseconds. Fine. And I'll say done. Now let's turn on this. See, slowly and gradually the intensity is increasing and the buzzing sound will also increase. Can you see the difference in the intensity? Just I'm sliding. The intensity and the sound is changing. See this. Can you see this? It is reduced. Even you can see the value on the slider. See this value is changing. So this is how I can do the intensity control. It's not the IP range, Vrushali. Our digital write, analog write can write maximum 8-bit value. And that 8-bit value is nothing but 2 raised to 8, that is 255. I can maximum write 255. Fine. What I'll do now, I'll add a button also and control one more LED here. Array. Now from the widgets, I'll take a button. So now I have a slider. I have a button. So on this button, I'll click. I'll select pin as D4 because see, D3 is already used. So I'm making it D4. Sorry. Okay. I'll make it on switch. I'll change its color to, let's say, purple. Fine, I'll increase the text size. And instead of button, I'll write here LED. Fine, done. And for this slider, I'll give the name as intensity. Done. Fine, so my both these things are ready now. Okay, I'll go back and I'll play this code. See, this LED has started blinking. Now it is blinking with full light. I'll just say off. It has been turned off. Again, I'll press this. So it has become on. And again, I'll say off. And when I say move the slider, so the maximum value goes to 255. You can see on the screen. This maximum value is you can see this maximum value is 255. I decrease it, intensity is decreasing, it is off, and this light is controlled. Off and then on. This is off, the light is off. So anybody, any difficulty in this application of what do you say, blink? See, once only I have written the code, but I'm just modifying the hardware, modifying some just writing, modifying the hardware. See, I've not again programmed the node MCU now. I've just changed my application. So anything, if you want to ask, just let me know. Now you can see, even since I've used button and the slider, both are of 200 energy level. My 2000 energy level has changed in the widget box to 1600. The moment I'll remove this, again the energy level will go to 2000. Yes, anything you want to ask? Anybody? Or is it clear? Just please let me know. Yes, students. If it is clear, just write yes. If you want to ask anything, you can ask. Or else I'll to move ahead. Anything, any difficulties, if you have, just let me know. Yes, Gita ma'am, is this clear?
Yes, sir.
Okay, Vrishali, clear, students. Okay. Now they are giving a message. So they are waiting for Geeta ma'am to respond, and then on everybody will respond. I think so. Okay. And I'll be giving you one small assignment also to all. Just I'm giving you right now a small assignment, and I'll give you just 10 minutes for everyone to write the code. Fine. I'll just turn on my whiteboard. I'll give you one small hardware, one design. You have to just write a code for that. So that at least I'll understand that how much you have understood. So within that much time, I'll do the setting of my ThinkSpeak, and then we'll come to ThinkSpeak. Today I'll explain you what is ThinkSpeak. Okay, what are the different parts, and tomorrow we'll go for the coding of ThinkSpeak. That will be the last part, I think so. So just let me start my whiteboard. Is this whiteboard visible?
Yes, sir.
Okay, okay, I'll just clear it. This is my C lectures data is there on that. Arre. Fine. So now what you guys have to do is, let's say this is my node MCU. Fine. On this, there is one fire sensor, let's say, which is connected to pin number D2. There is one gas sensor, which is connected to pin number D3. And I'm giving all the examples of digital sensors only. And let's say there is a touch sensor, which is connected to D4. Now let's say there is D5, D6, D7. To this D5, I've connected one LED. Fine. And that will give me the indication of touch. LED for touch. Touch LED, I can say. Then let's say on this, there is a buzzer, which will turn on when there is a gas leakage. And on D7 pin, I've connected, let's say, a fan, a motor. Fine. And what I'll do, instead of this fire, I can say this is a temperature sensor, which will give high or low. All the sensors are giving high or low. On active condition, high, and deactivated condition, they will give me low. So this is fan. So when there is a high temperature, the fan should be on, and for low temperature, the fan should be off. So students, I'm giving you 5 minutes. Write the code and share with me fast. You can write it in Arduino ID, or you can write it in what do you say, the notepad, wherever you feel like comfortable, write it. So here pin number D2, D3, D4 will be output. I may be wrong, you have to correct me. I may be wrong, you have to correct me. As well as pin number D5, D6, D7 should be input. So just define it whether they are correct or not. If they are wrong, just let me know what should be the correct thing. So I'm just giving you 5 minutes, make the system on complete. And I've given you some status of the pins. So let me know whether the status are correct or not. And if they're not correct, then what should be the changes and why, you should tell me. Chalo, do it fast and let me know who is writing the code first. I'm just giving you 5 to 7 minutes to do the things. And one thing I forgot to tell you, with this Blink app, you can control the applications from anywhere. Not only that you should be in the local system only, you can be anywhere, and Blink can be used to control the application. It can be used with Bluetooth within a short range. If you want to use, you can use Bluetooth, you can use Ethernet, anything. Even you can use GSM systems also. Yes, anyone did the code? Yes, let me know. At least I expect minimum 3-4 students, those who can do. Yes, anybody? Or shall we write the code?
Anyone? Any student has done? Even though whatever set of lines of code you could able to write, please put it in the chat box.
Yes, at least I'll understand what coding status is of yours.
Yes, Mir, Vrishali, Rohit, Shifa, Hussein, Om. At least say in the chat box whether you were able to do it or not. Write yes or no.
Because I want, like, at least somebody should be in a position to do this coding. Guys, at least try to respond to your ma'am also.
Vrishali saying, sir, that she is having unstable net connection. She can hear it, but she's not able to write it. That is not going.
Okay.
Students, are you there? What about others? What's happening? Why you people are not responding?
Because 57 are connected. Some 4-5 students, maybe because of the internet issue, may got disconnected.
Others, please reply.
Because tomorrow I'll give demonstration of one such system where I'd like to have some 3-4 different sensors and 3-4 different outputs, and we can switch over. Even I'll try to, if it is possible, I'll try to demonstrate 230 volts control, that how we can control 230 volts application. If it is possible for me, I'll do it, because to work with 230 volts in this live session. It is a bit difficult. गलती से हाथ कहीं 230 को touch हो गया तो I'll start vibrating.
Oh.
That is also there. So I have to take that care also, because at a time I have to handle my IP cam, I have to handle my screencast, I have to handle my PC, I have to handle the hardware, everything I have to synchronize it.
Okay, sir. Okay, few set of students are privately writing that they are not able to write the code. So better, sir. Can you explain to them?
Yeah, sure, sure. I'm happy
Yes,
to explain.
yes.
No issues. At least I should
Yes,
get updated. Fine, fine, fine.
yes.
Fine. We'll write the code. No issues. At least students, in between, I'll ask one small questions. You can at least respond to that. That will assist me in writing the code and even help you in understanding the coding. So I hope that much you can do, students. Fine. Okay, fine. Now they have started responding.
Yes, sir. Sir, don't ask them to write down the code. You just explain with the code only.
No, see, at least we should give them chance, na?
Yes, yes, sir.
Okay, fine. What we were having on D2 pin, we have connected temperature sensor. D3 pin, we have connected, I think, gas sensor and touch sensor. Here there is gas, and D4 pin, there is a touch sensor. Then we have taken on D5 pin a LED. D6 pin, we have taken a buzzer, and D7 pin, we have taken a motor. That may be a fan, you can say. So very first thing what I'll do, I'll declare the variable for all.
Sir,
So you can
sir,
write-
sorry
Yeah.
to interrupt. One student, Praveen, he
Ha,
has
ha, ha,
put
ha.
the code in the chat box. Can you
Yes,
see
yes,
that
yes,
code?
yes, yes. I can see. I can see. Very good. Chalo, our mehnat is successful.
Yes, good student, Praveen.
Yeah, very good. मैम थोड़ा प्रवीण को कंसीडर करना कॉलेज में.
Yes, sir.
So void setup, D2 input, D3 input, D4 input, D5, D6, D7 output. Very good. Then he has written temperature equal to digital read, digital read, digital read. Very fine. If temperature is high, very good. There is a mistake in digital write. Fine. Good try. Good try. Very good try. I think he has corrected the code and given again. I think so. No. Okay. Fantastic. Logically, the code is correct. Syntactically, it is wrong. Mistakes are there. A lot of mistakes. We'll see. Now, see, Praveen and others also very nicely has written the code. Very nice, Praveen. At least we cannot hear to each other, but at least and have an applaud for Praveen. At least have an applaud for Praveen. Now, see, very nicely has written Praveen. You have taken D3, D4, D5, D6, D7 directly. Now, suppose if I change these pins, D4 instead of D4, I say मेरा मोड चेंज हो गया. अभी आप एलईडी को D10 पे कनेक्ट करो. फिर आपको क्या करना पड़ेगा, जहां जहां पे आपने D5 लिखा हुआ है सब जगह आपको D5 चेंज करना पड़ेगा, या D6 चेंज करना पड़ेगा, या D7 चेंज करना पड़ेगा. So that shouldn't be the thing. Very good try, but I'm happy at least you have tried. I think that's why somebody was taking time. That it's a big code. Nice code he has written. Chalo, we'll see the same code in some different way. So let's say I'm defining 3 variables. Always when you do programming, define a variable. Now what was the sensors? Temperature. So write temperature equal to D2.
Sir, your whiteboard screen is visible. We are not able to see where are you writing.
Okay. Now?
Yes, sir. Now it came. Yeah.
Okay. Int. Then I'll write int gas equal to D3. Students, you have to bear with my handwriting. My handwriting is bit like jalebi. So int touch, I've taken D4. Then I'll take int LED. And you know, when you define these variables, it is always very nice that you need not have to remember the pin numbers. You have to just remember the parameters. So always while writing the code, you define the variables with the name of the components itself. So wherever the component connected, whether it's connected to D5, whether it is connected to D6, or whether it is connected to D7, fine. There is no issue. And you should be multitasking. Like, see, I'm talking also and I'm writing also. It should be like that. Now, once this is over, I'll write setup void setup. Now, in this, you will write pin mode. You will write temperature as input or output, students. Temperature should be input or output. Yes, temperature should be input. Why input? Shifa? Why input? Can anybody tell temperature, gas, and touch? Why they should be input? I'm not writing the pin mode again. I'll just write touch again as input. Please, it should be complete capital. Huh? I'm just writing the English format. It should be always capital. Why these three are input? Because all these are sensors, input devices. They will give the data to node MCU. Then you will write pin mode, LED. Sorry, B should be smaller. I'm not writing syntactically. Logically, I'm writing the code. And then you can have pin number, sorry, LED buzzer, and this as output. So all these three are defined as output. Now what you guys can do is, here you can write digital write. Digital write. Turn on the LED. LED. Hi. Turn on the buzzer. Hi. Turn on the motor. Hi. This is what is called a self-test. And then after a delay of 2 seconds, what you guys can do, you can turn off this like LED. Sorry. Buzzer and motor. You can make it low, so they will get off. Done. This is what is your setup. So I think till this point setup is clear to all. Yes, whatever I've explained in setup, it is clear to all. If it is clear, please just write yes. Okay. Fine. Now what I'll do? Void loop. Very good, very good. Now in this loop, what I'll write? If digital read, I can directly write even this way. Digital read, what I have to read? Let's say temperature. I'm just writing only one loop, not all the loops I'll write. Is high. What I'll do? I'll write digital write. What I was supposed to turn on? Fan. So that was motor. Motor comma high. Done. कुछ नहीं करना है, मोटर चालू हो गया. Then specifically write if digital write temperature equal to low. What you have to do? I'm sorry, here it should be digital read It should be digital read. Here I'll write digital write. What I'll write here? Yes, very good. Motor low. Very good, Hussein. Motor is low. Finished. Same way, I'll write the code for gas sensor as well as touch sensor. So what will happen? The moment I write it for gas and touch, once all this condition, let's say this was the condition for gas, this was the condition for touch, at the end you write delay of 2000. So after every 2000 it will take the samples and will take the scenario, or it will take up the conditions. So I hope this code is clear to all. Just simply instead of digital read temperature, you will write gas and you will write touch, and instead of motor you will write LED and you will write buzzer. Yes, is that clear to you? I hope everybody is understanding this. Very good, very good. Great. So within next 5 to 10 minutes, I'll just give a brief introduction about the cloud, and tomorrow we'll start with the ThinkSpeak. Or tomorrow we should start with the ThinkSpeak freshly. Yes, ma'am. Geeta, ma'am. Yes, madam. Madam is there? Geeta, ma'am.
Yes, sir.
Yeah. Shall I take a brief introduction to cloud today, or shall we start it tomorrow freshly?
Sir, tomorrow only better we'll do, no?
Because it's already 2 hours 40 minutes. Student might have tired. They started
Yes,
telling
sir.
tomorrow. Fine.
Before that also, sir, they were with the lectures only, na, so they
Yeah, I
must
can
be
understand.
tired
I can
only.
understand.
Yeah.
So tomorrow will be our last session. I'll be just one simple system I'll demonstrate with this code. The way I've given you the code right now, I'll just demonstrate one simple system, and then we'll end up with ThinkSpeak, so that our data will be transported to the cloud. And how we can use cloud, I'll show you that. So that will be like all the different things, basic system, then system with our what do you say, local server, and then Blink, that is one app, and one cloud. All the ranges I'm covering in this. So I hope students, everything clear to you, and I've already given you my number. If you have any difficulty, you can put a message on this number. So anything else, ma'am? Tomorrow we'll start with the next part, that is the cloud part.
Yes, yes, sir.